All right, part 2 of this. Okay, so this is going to be simplifying trig identities. Okay, and basically what you're going to be given is some kind of a statement, and you basically have to simplify it into more than likely one trig identity. Okay. The first, yep, so it says the cosecant times the secant minus cotangent. Okay. All right, so our goal here is to reduce this into one trig identity. Okay, so looking at your sheet, nope, it's just a minus.
So it's like
Yep. Cosecant. Yep. Okay, so looking at your trig identity worksheet, which identity could you use to manipulate one of these? You have a couple different options. So anybody know what cosecant is also equivalent to? Okay, 1 over close. 1 over sine. So cosecant is the same as 1 over sine, right? What is secant the same as? 1 over cosine.
So the ratio, I think.
What's that?
Right.
Yes. No. Oh wait, I don't know. What did you just say?
Yeah, the first ratio.
The first one? The reciprocals. The ratio one is for tangent and cotangent.
I know, but we have all the opposites. And then that is
Okay.
also
Cotangent is what? Say it again. I think you're right. Cosine over sine, yes. Cosine over sine. Okay. So the nice thing at this point is now we originally had 3 different trig identities, and now we're down to 2. That's pretty good. Okay, we're making things simpler. Okay, the next thing that I notice is that we are combining, or in this case, subtracting fractions. Okay, if we are going to condense this and squeeze it as one fraction, what do we need the denominators to be? The same. Okay, so we need to have the same denominators. Okay, the first fraction has a sine and a cosine in it. The second fraction has just sine in it. What is my common denominator? Sine times cosine, very good. Okay, so what does my second fraction need? A cosine. Okay, so I'm going to multiply the second fraction. Cosine. Cosine. The second fraction by cosine. Did I say that wrong? Sorry. The second one. What? Oh, you guys don't see that as 2? Okay. I see what you guys are not seeing that I'm seeing differently, I should say. Okay. The first fraction, yeah, this is one fraction, you guys. Sine times cosine. There we go. Okay, so now, common denominator. Still the same, right? It's sine, cosine. So my second fraction needs what? Cosine. So I'm going to multiply the top and the bottom by cosine. Okay, so at this point I have 1 over sine, cosine, minus, what is cosine times cosine? Cosine squared, very good, over sine times cosine. Okay, so now if I have a common denominator, what can I do? Subtract the tops, right? The whole point was to squeeze it together. Okay, so on the top I now have 1 minus cosine squared over the common denominator. Okay. All right, we're getting close. At this point, I look at the top and I notice something that's very obvious to me. Let's see if you can see what I see. What do you notice about the top? Okay, I'm trying to think of an identity to use. What identity is popping out to me? The Pythagorean identities, exactly. Why is it popping out to me? Because there is a squared, exactly right. So anytime you start dealing with things that are squared, especially if there's a 1 involved, that's going to be a Pythagorean identity. Okay, so which Pythagorean identity am I going to use? And I'm going to write this on the side so you can see how I'm thinking. Which one has a cosine squared in it? Right. So this is the one I'm looking at. Sine squared plus cosine squared is equal to 1. Okay, so at this point I notice that it's set equal to cosine, or there's a cosine in here right now. It's kind of wishy-washy. I can't really like replace anything as it is. I could replace the 1 with sine squared plus cosine squared, or what I could do is I could set this equal to sine squared. Okay, so everybody looking at the green equation, right? If I was going to set it equal to sine squared, how would I get rid of the cosine squared? Subtract it. And I'll show you why I wanted to do that. Yeah. You see how that is exactly the same now as the top over there? What's that? Yep. Okay, so now what I'm going to do is, since 1 minus cosine squared is equal to sine squared, I'm going to replace that with sine squared. Cross what out? You're very close.
Wait, what did you do?
Okay, so all I did is I replaced the 1 minus sine squared, or excuse me, I said that wrong, 1 minus cosine squared with sine squared because they are equivalent. I did a substitution. See how I'm, this piece right here? Substituted that in. Okay, so now if I have sine squared over a sine, one of them cancels out, just like x squared over x. One of them canceled. So what am I left with? Sine over cosine, which is equivalent to tangent. Very good. Tangent. Boom. Done. This is hard. Shall we do another one?
What is cotangent?
What is the point? What was that?
Cotangent is equal to cosine over sine.
Cotangent? Cotangent is cosine over sine. Tangent is sine over cosine. Correct. Yes. All right, let's do another one. Let's do this one. Okay, so this is sine squared of x times the cosine of x minus the sine of pi over 2 minus x. Who is it? Oh, sure, I guess. Okay. All right, so what are you thinking?
The bottom ones.
Okay, so immediately Scott says we're looking at a cofunction identity. Why are we looking at a cofunction identity? Has that pi over 2 minus the angle 2. So since we have a sine of pi over 2 minus x, what is that equivalent to? Cosine of x. So this piece right here is the cosine of x. I'll go, we got cosine of x. Okay, so that's by the cofunction identity. Everybody follow that one? Good? Okay, now what?
Yeah.
Pythagorean Theorem it? Okay. I'm going to do one thing first, if that's okay with you. Yes, I see the Pythagorean Theorem. It's not wrong to go there, but it will take longer to go there. Just because I've practiced this a lot of times, I just know that. Okay, so when I see two terms like this, I always want to think about a greatest common factor. Okay, so pulling it out so we can eliminate subtraction. Do I have a greatest common factor that I can pull out? A cosine. Okay, so if I pull a cosine out, we're going to have a cosine of x. What's going to be left with the first term? The sine squared of x. What's going to be left of the second term? 1. Good. Okay, now what do you see? Okay, so what Pythagorean identity are we looking at again? Same one. This one is like, they love this one. It is used so often. Okay, so in this case, I have sine squared minus 1. So if I take my Pythagorean identity, the blue piece, and I set it equal to the cosine squared, what would I do? Subtract it. So it wouldn't be a bad idea for you guys to write these equations, the ones that I'm writing off to the side, on your Pythagorean identity sheet, so you have them there and you don't have to like mentally convert them. Okay? So now we can replace 1 minus, yep. So we can replace 1 minus sine squared. No, wait, what did I do? Hold on, I must have screwed this up. Okay, perfect, very good. So, should I show the work for that? Okay, let's show the work. Hold on. Because see how it's opposite? I have 1 minus sine squared. That's not exactly the same as sine squared minus 1, right? Okay, so I'm looking at this piece right here. This is just like the two problems that I did today on the, what was it, the cofunction. If you switch the order, exactly, and then take out a negative, this will be sine squared minus 1, which is exactly what I want. Okay, so if this is equal to the cosine squared, what can I do with that negative? Not totally just get rid of it, but just throw it to the other side, right? So that's equal to negative cosine squared. Okay, so now I can replace this. This will work now. Okay, so now I have cosine times negative cosine. So, what's cosine times negative cosine? It would be negative. What's that? Oh, squared. Oh, yes, sorry. Thank you. You're right. To the third. Okay. Now, what if I would have done this problem the way that Mari had suggested? Do you guys mind if I go ahead and just play that spot and just see what it would look like? So, Mari suggested at this point right here, we'll kind of draw a little line. She said, immediately she saw that sine squared and wanted to use a Pythagorean identity on it. Okay, so let's say we would have done that. What is sine squared equivalent to? Is anybody following that? Okay, so if I look at my sheet again, I see sine squared plus the cosine squared is equal to 1. So sine squared is equal to 1 minus the cosine. I just subtract the cosine squared over. Okay. So now if I replace the sine squared, it would be 1 minus cosine squared. Okay, what would you do at that point? What's that? Give up? Oh, well, you could like distribute, right? So this would be cosine minus, what's cosine squared times cosine? Cosine cubed. What do you notice at this point? The cosines cancel out, yeah. Well, maybe not. Maybe it's easier. Maybe that made more sense.
No, it's still.
Okay.
Where would we use this?
You use this in solving trig equations, which is going to be the next thing.
This is the hardest one.
This one is harder. Simplifying is harder than solving equations.
But don't you simplify while you're solving?
Like when you're solving the equation?
Yeah.
Yeah.
Do it though.
Yeah. But it's usually not as complicated. It is harder. I don't know, it just is. Okay, let's try another one. Okay, so we've got the cotangent of x minus cosine cubed of x times the cosecant of x. Okay, so where would you start? There's definitely a lot of options for this one. I think that's a very good suggestion. If you guys are always thinking of in terms of sine and cosines and tangent, then go there. Make things look like sine and cosines. That is, if that's easier, let's do that. So what is the cotangent the same as in terms of sine and cosine?
Cosine over sine.
Okay, so we have cosine over sine minus. So since we have a cosine cubed, let's keep cosine cubed as is since it's already cosine. And then what's cosecant the same as? What? 1 over sine, good. Okay, now at this point, I'm not sure if everybody realizes this is just two fractions that are being subtracted, right? Okay, if you want to squeeze this as a step, that's totally fine. This is cosine cubed over sine. Okay, so now if I'm subtracting fractions, I need a common denominator. But I have a common denominator. Check. Perfect. So what can I do on top? Subtract. I can go straight into subtracting. So this gives me the cosine of x minus cosine cubed over the sine of x. Okay. Now what? How? That is true, but you can't separate it. I mean, yeah, that'll just get you like right back to where we started. Because if you can't just say I'm only going to divide only the cosine by sine. You have to divide both pieces by the sine. So we need to play with the top. What can we do on top? You can what? Good, you can pull out a cosine, very good. So if you pull out a cosine on the top, what's left over at the first term? But don't forget the 1 because you have to have a placeholder. 1 minus a cosine squared. Okay, now do you see it? There's that cosine squared piece again. So what's 1 minus cosine squared equivalent to? Do you have that written down? Sine squared. Sine squared by the Pythagorean identity. Okay, so now what can you do if you have a sine squared over a sine? Cancel them out. So we're going to have a cosine times a sine. And can we condense that any further? Is there anything that is equal to cosine times sine? No. Okay, so this is simplified. This is a rare case that you see it not condensing into one trig identity. Brain break? You ready for me to give you the assignment?
Yes.
And try it on your own?
Yes.
Okay. Alright, so it's still on the same page, and I'm going to give you 22 through 36 even.